everyone. Good morning. The authors and invited guests, welcome to Technical Session 7B. Myself, Ishita Sauran, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 8th World Conference on Smart Transit Systems, Security and Sustainability, WS4 2024. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through Zoom from 24th to 26th of July 2024. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session. We have with us Dr. Bitan Mishra, who is currently working as an assistant professor in the Department of Computer Science and Engineering at Techno International Newtown, Kolkata, West Bengal, India. She has served as reviewer in many peer-reviewed journals and conferences. Her main research interests include optimization techniques, deep learning, evolutionary algorithms, and soft computing techniques. She has worked as a reviewer on several national and international journals and conferences. We welcome you, ma'am. I'd like to welcome, ma'am. I'd like to introduce you all to, for the second chair of the session, Professor Lawrence Mashal, who is a part-time lecturer in the Department of African Languages. He has worked for over 5 years in the higher education sector. He specializes in sign language, social linguistics, and legal linguistics, skilled in teaching, facilitating, research, time management, writing and editing, communicating, digital communication presentation. We welcome you, sir.
Thank you.
Thank you, sir. We'll be proceeding with the papers. I'd like to invite the first presenter of the session, Matija Burek, with the paper titled AI in Veterinary Ophthalmology, Canine Eye Diseases Diagnosis with Image Segmentation and Large Language Models. Sir, if you're here, then you may start with your presentation.
Hello. Thank you for the introduction. I hope you can hear me, right?
Yes, sir, you're audible.
Okay. Here's my presentation. Just a second to share the screen. Entire screen. Okay, can you see my presentation?
Yes, sir, it is visible. Please go ahead.
Great. Okay, so like said before, my name is Matija Buric, and I will give you an insight in our research about implementation of AI in veterinary ophthalmology, which is the part of the research I'm doing with my mentor, Marina Ivasic-Kos. So without further ado, let me say what this presentation will consist of. So I will give a little introduction to the field, say something about semantic segmentation, which I'm performing in the first part of the research, then system interpretation using LLMs, say something about, describe the experiment used, and conclude with conclusion, of course. So, what is the motivation for this research? To provide a complete diagnosis based on image of a canine eye. So how do we do this? We first build a data set, custom data set, perform some semantic segmentation, pick the optimal solution, use this segmentation to identify symptoms presence, and try to interpret symptoms to diagnose disease using LLMs. When we talk about those diseases, there are more than 50 classified eye diseases in canines, in dogs. So there is also a variety of symptoms describing those diseases, and we picked 4 for this stage of our research. And those 4 distinguished one, you can see in the image. S1 is ocular opacity. It's some haziness or cloudiness over cornea. Cornea is the center part of an eye. Then the second symptom is scleral redness. That is when blood vessels in that white part of an eye are highly visible, something like a red eye. And then we have epiphora. It stands for excessive tearing. And the last one, S4, is colored ocular protrusion. In this case, we focused it on the corner of an eye. On the right side, you have a list here showing the combination of those symptoms which point to specific disease. These the symptoms, combinations, and this identification of diseases are taken from the Atlas of Canine Ophthalmology Diseases. So that's more or less about the subject. So what we have done at this first part, we used UNet model, which is more or less having the focus on medical images. It consists of a coder and decoder side. That left side is a coder side. We have an input image on one side, and we expect segmentation map on the other side. This improved UNet model, which we used, uses a backbones, which are pre-trained on ImageNet dataset to leverage transfer learning. So here are the results, preliminary results of the segmentation using that improved UNet on only 200 images. And you can see here we tested four different backbones, and the ResNet backbone showed us that showed to be the best solution here. On the left side, you have those images, which shows clearly that the segmentation is satisfactory. However, we have problems with segmenting excessive tearing, which is not so unusual because the humans also have problems with segmenting or annotating the excessive tearing in images like this. Then in the next step, we take those symptoms and then we push them to the LLMs. So we picked two versions of GPT, Gemini, Mistral, Claude, and Llama for this part of the experiment. And as you can see here in this table, it is important to engineer the prompt correctly and to give it some context, and also from the upper side of the table, you can see that this prompt was generated using the troubled dog owner without precise definition what the symptoms are, and what could be the problem with the dog. This was fixed with using a UNet symptoms describe. And you can see here in green color, the glaucoma was the diagnosis, which is ground truth for this combination of symptoms. Also, we tried, but this is limited to only a few LLMs, to push the image into LLM and expect it to give us the result, give us the diagnosis. However, also what we noticed that if we push the image and the mask generated from UNet, that we get a better results. Also in green color, ulceration is the disease that we were hoping to be identified. And in the lower table, you can see that we finally decided to use the short answer with the two dual diagnosis from all LLMs to make it possible to compare it fairly. So you can see that GPT-4 has single diagnosis. When single diagnosis is used for cherry eye, it has no trouble defining it. However, Gemini doesn't perform that well. It performs okay when dual diagnosis is used, but like I said, some symptoms are more easily interpreted than others, where GPT and Gemini managed to identify eye trauma in the dual diagnosis alone. Here are the results based on the metrics for LLMs, common metrics for LLMs, which corresponds to best performance of GPT models, GPT-4 in more particular. And when dual diagnosis is used, LLama also shows some results, significant results. However, when we point to that left diagram, you can see from 15 diseases, ground truth diseases, GPT managed to correctly diagnose 9 of 15 in single diagnose or 10 in dual diagnose, and the Lil Llama is in fact the worst one here. Also in the right diagram, you can see based on the certain symptoms how well the GPT performs. So when we have symptoms alone, not in combination, then the diagnosis is better compared to those when we have a combination, especially with those combination that has symptom one, that is that hazy cornea or hazy center of an eye. What we can conclude from this research, that integration of computer vision and LLM is applicable in veterinary ophthalmology. LLMs performs well, but GPT-4 performs the best. UNet model recognizes specific ocular symptoms, and if trained on a large data set, it can probably be even better. LLMs can diagnose based on described symptoms from UNet, and combination of image segmentation and sophisticated text analysis optimizes diagnostic accuracy. Of course, further research is needed, and it is expected that with the bigger data set, the segmentation would be better, and also with the popularity of LLMs, which are released daily, we can expect to even have the segmentation and object detection not developed, but performed using LLMs alone. However, we also did some research, and at this point, they are performing poorly compared to UNet. I hope this presentation was interesting, and thank you for your time. And if you have any questions, I'm here willing to answer them.
It was a very great presentation. No question from my side.
Okay.
That's great presentation. I just want to find out which sampling technique did you use to select the dogs that you examined using the tool that you are presenting on?
Sorry, which segmentation
Sampling
method?
technique, sampling method, yes, to select the dogs that you used for this study.
Who selected them? So we have specialist, ophthalmology specialist for dogs, veterinarian, who picked those images. And in fact, these images are from, he's an author of the atlas that we used for our research, just to have the expert knowledge in our research.
Oh, okay, maybe let me rephrase my question.
Okay.
Remember when you select, first you will have a target unit, then you will have your sampling size, but remember you will have many dogs. But you cannot examine, let's say, 1 million dogs. You have to come with a technique to select dogs that
which
you
one?
can use to generalize.
Yeah,
so I just want to know the technique or the method that you used to select the dogs that you tested your technology with.
So unfortunately or fortunately for dogs, there aren't many sources where we can find images. So for training, we only had 200 images. So to find to pick the right way to collect those test images, in fact, answers that we don't have much space to search for those images. So we used what we got, and we didn't pick too much because we didn't have a lot of images to pick from. So we used the images from the laboratory, or not, but from the clinic that specialist provided in that atlas.
Oh, okay.
I
Thank you.
hope that answers the question.
Okay, thanks.
Thank you, sir. We'll be proceeding with the next presenter.
Okay.
I'd like to invite paper presenter Adrienne with the paper titled Deep Reinforcement Learning Model for Cognitive Skills Improvement. Ma'am, if you're here, then you may start with your presentation.
Hello, everyone. Thank you all for the opportunity to present our study. I am sharing my screen right now. Okay. All set?
Yes, ma'am, it is visible. Please go ahead.
Thank you so much. Alongside with my research mentor, Associate Professor Penka Georgieva, we are working on architecture, as long as right now it's yet a prototype, for deep reinforcement learning model for cognitive skills improvement. It's a more personalized model, which will find individuals' cognitive abilities as various intelligences. Why? Because right now, most of the cognitive tests are pretty structured and they lack that kind of personalization. Okay, we will go through the theoretical foundations. I will present you multiple intelligences. I will present you the multi-agent deep Q learning method and the main architecture itself. Okay. Throughout the years, actually, there are many definitions for cognitive skills. Mainly, they are presented, and the definition is like for higher order mental processing skills. But if we talk about 21st century skills, scientists from Princeton University define 21st century skills are as cognitive, interpersonal, and intrapersonal skills as a combination. And why we need that? In the dynamic job market, the personalization and the personal expression of someone is really highly valuated. And so that's why we are working on a tool where you can, from early age, can start develop your cognitive abilities. As a foundation, we are using the theory of multiple intelligences, mainly started from Professor Howard Gardner from Harvard University. And he states that there are 8 types of intelligences, which are combination and from cognitive abilities from various types, such as logical, mathematical, naturalistic, intrapersonal, visual spatial, musical, bodily kinesthetic, interpersonal, and verbal linguistic. It is mainly used in kindergartens, but we can see someone as even a grown adult as a combination of them. And because we have our mind, ourself as a dynamic environment, we are using deep reinforcement learning as a method to determine the best actions, which leads to the maximum reward for each state in the dynamic environment. There is an agent which classifies and uses deep neural networks. He sees its state and depending on the policy, he takes action A. After that, the environment returns a reward or penalty. Okay, the main multi-agent deep Q network is consisted of 8 agents. Each of them is responsible for a different intelligence. So how this will happen actually? Through gamification. A standard games, but they will be the results will be classified into stated in a simple buffer for each agent. For instance, for linguistic intelligence, we will use word plays like puzzles, or vocabulary usage like story games. For logical mathematical intelligence, we can use numerical analysis, algorithmic thinking. For interpersonal intelligence, we can analyze how a person is managing with conflict resolution, goal setting, and so forth for each intelligence. After you play the game, the results are going and are stated in a dynamic environment, which also returns a result to the others. So they're mainly agents working cooperatively. This is a table representing how we will score the results. We are using fuzzifications, and for characteristics, we are representing them in 3 states, like low, medium, and high. After that, the result itself will go into the input node in the neural network. In the deep Q network learning, we are having main network, which outputs the Q value, and the target network, which is like a hidden network, which actually it's playing like a shadow network. And so for each agent, he will have reward, next state, input state, what action to have, and the actual entry. So the key features in our system will be, they are mainly like the personalization, the real-time refinement during the play time. Right now, we are working and constructing the model in Python. Currently, we have the main network, and we are creating agents itself. Okay, and I would like to thank you for your time, and if you have any questions, I will be happy to ask.
Thank you. From my side, I have no questions.
Okay, thank you.
Thank you, ma'am.
Thank you.
We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Sajida Rashmawati with the paper titled Empowering Smart Healthcare Governance, a Holistic Approach for Information System Maturity in Indonesian Private Hospital. Ma'am, if you're here, then you may start with your presentation.
Okay, thank you, Mrs. Isita Sorian. I will share my screen.
Sure, ma'am.
I need to permit to share screen.
Ma'am, you can try again.
Okay. Okay. Yeah. Okay, good morning, ladies and gentlemen. Allow me, my name is Indro Sajida Rahmawati from Talam University in Indonesia. My major is Information System. Today, I'm honored to present my research finding titled Empowering Smart Healthcare Governance, a Holistic Approach for Information System Maturity Indonesian Private Hospital. I hope that my research can be beneficial to fellow research and contribute to advancement in the field of healthcare governance. So I have 5 steps. The first is abstract, introduction, literature review, discuss, and results. So the last is conclusion. The implementation of modern technology, the strategy aims to integrate patient-generated and personally collect health information into clinical research products. We implement a standard framework to meet the necessary criteria for digital data in medical study. The infrastructure we have designed enable the collection, transmission, visualization, and analysis data to send by sensor and user utilize a cloud platform for collaborative data storage and ensure a real-time localization. Although there is potential for intelligence healthcare innovation to information integration, challenges such as multimodality, timelines, and quality consistent need to be addressed as they impact information and discussion. The study shift is focused to smart healthcare, aim to overcome challenge in the maturity of information system by adapt to HISM framework, Hospital Information System Maturity Management. So, the primary goal is to assess information system maturity comprehensive, address bureaucratic and organizational resistance to innovation. It's to identify infrastructure factor in the adoption of advanced health information system and emphasize the significance of effective smart healthcare planning as a strategic factor in the healthcare sector. By integrating assessment maturity, perception, and smart healthcare for digital transformation alignment through the HISM framework. Yeah, the study presents a holistic solution to enhance the maturity of hospital information system. This framework is positioned to improve healthcare delivery overall efficiency and effectiveness. The study recognized the challenge of adapting smart healthcare service and highlight the role of information system maturity assessment in improve current maturity if properly implemented. So the framework is HISM, Hospital Information System Maturity Management. These frameworks offer a specific and relevant method for measuring information system maturity in the hospital, addressing critical aspects unique to the healthcare industry. It can be tailored to the context and specific needs of individual hospital to accommodate the diverse range of service from medical care to patient administration. This framework shows flexibility to adapt for maturity measurement to various hospital process and system. Enable to evaluation to the complex environment additional to the health informatics, also known as clinical informatics, medical informatics, or biomedical informatics. Refers to the field of information science focused on managed healthcare data and information. The first solution result from this paper is bridging component in smart healthcare solution. In this figure, staff registration with process data patient, database patient medical record information system, connect to medical record, staff electronic medical record with process the medical record, and the last process is recapitulation exposition with output is head of medical record department. The medical record system analysis data flow is a crucial element in smart healthcare. The illustration complex data network within medical record and its role at advancing healthcare initiative. The graphical representation highlights the importance of leverage medical record data to enhance healthcare process, promote both efficient and waste data utilization. The next is evaluation of current maturity level. The maturity assessment of our whole information system across various stages and attributes. In this chart, we evaluate 6 key attributes: data analysis, strategy, people, electronic medical record, information security, and system IT infrastructure across 6 maturity stages. After analyze all the attributes across the stage, the overall maturity level of our whole information system, the result is current level maturity is number 2. This indicates that while there are areas with high maturity, such as strategy and system IT infrastructure, other areas still need improvement to achieve higher maturity level. So, the conclusion for this paper is Smart Healthcare Architecture Review. A strong technology infrastructure is essential for support smart healthcare. This includes having a fast network, data security, sufficient cloud storage. Building this infrastructure is crucial for a robust smart healthcare system. Here are some key considerations for planning and construction such as infrastructure. Well, these attributes are important. They need a creative approach to perception to turn them into valuable service. This is the main challenge for strong smart healthcare application. A clear vision and scalable step-by-step approach are crucial for creating simple, functional, and sustainable service. So our recommendation focus on develop a resilient smart healthcare vision for modern urban area. Engage in involve various local stakeholders is essential for this process. This is the figure of conclusion smart healthcare architecture overview. The structure of smart healthcare system, which is divided into 3 key layers: the perception layer, network layer, and application layer. The first one is perception layer. At the foundation, we have the perception layer, which contains the medical database. This layer continuously updates with new data, ensuring that the most current information is always available. The second one is network layer. Moving up, we have the network layer. This layer consists of network transmission, network service component. Network transmission handle the data flow between the layers, while the network service ensure reliable and secure communication. And the last one is application layer. At the top, we have the application layer, which include 2 main applications, the medical information application and medical information decision-making application. This application uses the data transmitted through the network to provide valuable insight and support for medical professionals in their decision-making process. In the summary, the perception layer collects the update data. The network layer ensures seamless and secure data transmission, and the application layer utilizes this data to support medical application. The structured approach allows for efficient and effective smart healthcare solution. Thank you for your attention. If you have any question, please feel free to ask.
Okay, I have a few questions. First one, I just want to know the study unit, did you use urban healthcare institution or rural healthcare institution? Then another question, which methodology did you use to explore this study? Then number 3, what are the limitations that you have identified during the course of the study? Then the last one, what is the main contribution of this study? Those are the questions that I have for you. Thank you.
Okay, thank you. Challenges are identified in the digital transformation of local governance in Indonesian private hospital. The challenge in this paper I identify in four concepts. The first is multimodality. The integration of various types of data information source can complicate the digital transformation process. And the second is timelines. The process is ensure that data is collected and processed in a timely manner is crucial for effective healthcare delivery. And the third, consistency of quality. Maintaining high-quality data across different systems and processes is essential but can be difficult to achieve. And the last challenge for this digital transformation is information seeking in the information sharing and discussion. Challenge arise in how information is sold and discussed among healthcare professionals, impact decision making and collaborative.
Okay, thank you.
Okay, thank you for this discussion. I will back to Ma'am Isita Soren. Thank you.
Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Rafian Ramadhani with the paper titled Integrating RSM Design Approach in Developing Web and Mobile Applications for Construction, Project Management, and Home Services. So if you're here, then you may start with your presentation. So Rafian.
Okay, wait, I will share the PowerPoint. Wait. Can all see my presentation slide?
So it's not visible yet.
Oh, okay, can see?
Yeah, it's visible now.
Okay, I will start the presentation for my research paper. The title is Interpreting LSM Design Approach in Developing Web and Mobile Application for Construction, Project Management, and Home Services. By me, Rafian Ramadhani. And next, the background of the research is first is about a role of the construction and renovation industry, and is a big goal in this my place I researched this paper. And the next is potential of technology in addressing challenge, and also the industrial 5.0 and 4.0 and 5.0 is IT technology is main character in this developing technology. And the next is curve the construction sector in this Banyumas city that place I research is number 1 and number 2 in sector business about non food and non grocery in Banyumas city. And this one is construction sector and home services is number 1 from survey from PPS survey. And the next is requirement for construction project management application is many functional requirement then needs in the construction project AI conduct in this application. And next is trend of digitalization in industrial sector. Just many industrial digitalization in IT to IT sector. And third is modern customer expectation. The customer expectation wants to use apps and flexibility to order home services by phone or by web. And the next we develop, and the next for the backend we have two objectives, which is first is development of application with structure methodology, which means we use RSM, and the next in implementation of RSM methodology or design approach, and this application become a transition to digital era. And next, the literature review, we get three main literature review, which is first in technology in construction management, and the third is RSM, design approach is recognized, and marginalized, and the third web and mobile technology for construction application. And this the methodology I will present. The first we do recognize we benchmarking with another apps launch, and the next is develop user person from the we use a method for interview to user, and next is Goodnice is user-centered design. We design this app from UI UX with Figma. And the next prototyping and tests, we produce the application using Next.js, JavaScript, and the next test we use UAT. And the next step is the third step or last step is materialize. The materialize from UAT and user testing. We get a feedback to improve the application, and the next is implementation key, feature, and launch. And also we launch the application to Google Play and hosting by web. And this is repeating from my I show. And this is the phase for admin to manage project. Is admin supervisor in this place in this project can upload the evidence, and also I become customer can see the progress for evidence that upload by supervisor or admin. And the next detail order is the detail order from AC services. This there is a vendor prices and use voucher. And next is create order by user. There is input services or name, email, and also the number of help. And this is conclusion from my research is first operational efficiency and benefits by providing systematic user-friendly platform for managing construction project and home services. This application enhance operational efficiency and productivity. Thus, the supervisor or project manager can upload evidence. Also, customer can see the project progress, and also is efficiently to maintenance the project. And the second is improve communication oversight. This application improve project communication and oversight. Also, I thought before I thought yes, this can communicate from the evidence, and customer can see the evidence. And the third is relevance and technology innovation. It has potential revolutionary the field enhance user satisfaction. Thus, user can interact in application to see and give a notes for a project, and also give enhance expected we enhance user satisfaction. And this my presentation is completing the presentation. Any question? I give back to moderator. Hello, Miss.
So would you like to ask any question?
No, from my side, I don't have a question. Thank you.
Okay. Thank you, sir. We'll be proceeding with the next paper presentation. I'd like to invite paper presenter Osmani Kuma with the paper titled Machine Learning for Striga Detection in Cereal Crops in Semi-Arid Areas. So if you're here, then you may start with your presentation. Sir Osmani.
Hello.
Yeah, so please go
I'm
ahead.
here. I share in my screen.
Sure, sir.
You see my screen?
Yes, sir, it is visible.
Is okay?
Yes, sir. Please go ahead.
Thank you. My name is Usman Khouma. I'm a teacher trying University Amadou Mahtar Mbow, Dakar, Senegal. The work I present concerns machine learning for Striga detection in cereal crops in semi-arid area. The outline of my presentation: introduction, impact of crops yields, economic and social impact, supervector machine for effective Striga detection, result and conclusion. Introduction. Ensure food security stands as pronounced concern for our government. In Africa, the presence of Striga with serious compromise food production. Striga infestation exacerbs existing challenges such as unpredictable weather patterns and soil degradation. This infestation often results in significant crops losing or complete production failure. At present, the limited resources available to farmers are exacerbating the spread of the parasites. Information and communication technology offer a promising alternative to help farmers combat this pest. They could make it easier to detect striga in fields that are virtually inaccessible. To this end, the development of applications based on artificial intelligence is crucial. In our paper, we initially apply machine learning. After reviewing literature, we opted for the supervector machine for the earlier detection of striga. The choice was motivated by the fact that SVM is not only binary, but also better suited to identify the presence or absence of a feature in image. Impact on crop yields. The parasite plant striga attaches itself to the roots of hop crops, establish a connection with their root systems. It actively drains nutrients and weather from the host plant, leading to unequal competition that weaken the host plant and hamper their growth and development. The collective impact of striga on cereal crops can be devastating for yield, causing significant loss and in the most several cases, a total reduction in the harvest. This decline in agriculture productivity can have substantial economic and social repercussions affecting farmers' livelihood and contributing to food insecurity in the affected region. Economic and social impact. The economic and social consequences of cereal infested by striga are significant. Crop losing, striga drawing nutrients from host plant result in reduced crop yield. Crop loss can be severe, leading to food insecurity for farmers and their families. Reduced farm incomes. Crops loss caused by striga can have a significant impact on farmers' incomes. With reduced yield, farmers may find it difficult to meet their basic economic needs and pay for their children's school fees, healthcare. Cycle of poverty. Repeat crops losses due to striga can trap farmers in a cycle of poverty without access to the resources they need to combat this threat. They can find themselves in a precarious economic situation with later change of scabs. Land degradation. Striga infected farmer may suffer further degradation due to reduced yield and potential abandon and land by discouraging farmers. This can lead to reduced soil fertility and general environmental degradation, increasing reliance on pesticides. In some regions, farmers may compete to use pesticides to control striga. However, this can lead to long-term environment, public health, and economic problems, including pesticide resistance and soil and water contamination. Rural-urban migration. Farmers facing constant losses due to striga may be forcing to leave their land to seek economic opportunity in urban areas. This can lead to an increasing in rural-urban migration. Supervector machine for effective striga detection. We propose an architecture for an alert system and detection support tools to classify images taken in a serial field. The system architecture is made up to several parts: image getting, satellite and drone give us image to process. Treatment center, the image collecting will first to be processing before being assigned to a plant class, healthy plant or striga plants. Internet will play the role of data transport and interconnection of application server and other system entities. Application server and database management system. This part is made up of application server, web, mobile, and database. Web and mobile application. This can be used to view the result and plan classification and suggest action to be taken. SMS alert. A system for sending short message will provide timely information on the extent and serial crops fields. Detect data collection and pre-processing. Acquire a dataset comprise imaging feature both crops affecting by striga and unaffected healthy crops. Feature extraction. Derive significant attributed from the pre-processing images. This involve capturing color history. Training data preparation. Driving your dataset into training and testing subsets, ensuring a balanced representation of both striga infected and healthy crops. Model training. Employ SVM classify training the extractive feature. SVM are well suited for binary classification tasks such as determining whether some kernel function, linear, polynomial, radial basic, and sigmoidal. Result. The goal is identify to present or absence of striga in serial field by classifying imaging into category healthy plant coding by 0 and infected by striga coding by 1. After test and training dataset, we obtain confusion matrix, the matrix confusion result. The precision in the first columns. The precision of the striga class is 0.89, which means that when the model predicts the striga class, it is correct about 80–90% of the time. The macro average is unweighted average of the precision of each class, here 0.63, indicating an average performance across all classes. The weather average is here, is calculated by taking into account the number of samples in each class. Here, 0.77, which suggests an overall performance weather by the number. The result indicates that the model has better accuracy for the Strega class than for the healthy plant class, and that its overall performance is better for the Strega class due to higher weather in the data. We are evaluating our model and testing a new image. We have a healthy plant detected. This figure shows how effective our application was processing and classifying image or healthy plants. It able to correct, recognize, and categorize this condition. And another image, Strega plant detected. This figure highlights the ability of our application to accurately identify plant affected by Strega, offering a promising tool for the earlier detection and management of this devastating infestation. Conclusion. Addressing the pressing issue of Striga infection in sub-Saharan Africa is crucial to guarantee food security, particularly for small-scale farmers who endure substance cross-losing. Information and communication technology, notably those incorporating artificial intelligence like supervector machines, SVM, present helpful for earlier detection and management of Striga. Thank you for your attention.
With the next paper presenter, I'd like to invite paper presenter Varsha Nayak with the paper titled Ontology-Based Legal Knowledge System for Check Bounce Cases in India. Ma'am, if you're here, then you may start with your presentation.
Yes, please allow me to share my screen.
Yes, ma'am.
Is my screen visible?
Yes, ma'am, it is visible.
Yeah, hello everyone. My paper ID is 219. My research paper title is Ontology-Based Legal Knowledge System for Check Bounce Cases in India. I'm presenting this paper with the help of my co-authors, K. Rajeshwari madam. So here the aim is to design and develop a legal question answering system that can answer questions related to section 138 as per the Indian Penal Code. Now, significant technology advancement in the legal system has led to the shift towards paperless system in the Indian court. This has happened after the COVID time. And e-judgments demands information retrieval techniques to extract legal terms from e-judgments. So we are trying to develop information retrieval techniques using ontology-based extraction. So here, as I have displayed in the image, a sample judgment I have shared, which is unstructured document of varying length. So this e-judgment may be of 10 pages or it can be go up to the 40-50 pages. So this is basically a long document which is highly unstructured and complex. So our aim is to extract the relevant information from this judgment. So here in our case, there are number of IPC sections are available, but my focus will be on IPC section 138 because Indian Penal Code sections are broad or subjective, leading to varying interpretation and applications. Whereas IPC section 138, which deals with the dishonor of checks, is a less subjective area of laws. So that's why I have chosen this section 138. So here the aim is to create or develop an ontology which can encompasses multiple classes and their attributes with the relationships. So for this, what I did is I have created a data set. So for that data set, I have considered 50 judgments, which I shown earlier in the image. And from that, I have chosen different fields. So the dataset basically manually created by downloading a sample documents from indianqanun.com, where e-judgments are publicly available. So each file we individually assessed to extract relevant data. For that, we have to retrieve a prominent features or fields. So we determine this by brainstorming, and based on that, we have identified the prominent fields. So from this, after brainstorming, what we have got is the resulting data set, which had the following columns. So along with this, I have also given examples from the Indian e-judgments. Now coming to the methodology, there are two major parts of question answer analysis system. Here, the naive user can give the question, and then in the first part, the question analysis will be done, and the latter part, answer retrieval will be done. So as you can see here, the first step is pre-processing. After that, the semantic analysis is done. So as a part of pre-processing, first, whenever user will give a input question, so it will be first segmented as a part of text segmentation. So that question can be, or the sentence can be splitted into the tokens by removing the stop words. Further, part of speech tagging is done by labeling the tokens according to the grammatical part of speech. And then their categories are given like nouns, pronouns, verbs, adjective, etc. Further, the most important part which is required for ontology building is identifying the entities and relationship. So for that, we have a technique called as named entity recognition. So for that also, we have used models, NER models, which identify entities within the text. And it also extract the meaningful relationship between those entities or between those concepts. Further, after doing this pre-processing and semantic analysis or understanding the context of the sentences, it is given to the knowledge graph. So those entities and relationships are converted into the triple format, which is required for ontology, that is called as predicate, object, subject. And then it is represented into the knowledge form. Once this graph is built, it is a hierarchical representation of concepts and relationship. So we can easily search the retrieved data, the important data from that graph. So that is what about the ontology, which gives the formal visual representation of knowledge with the help of entities and relationship. So it has basically key components such as classes, instances, attributes, and relationships, and some constraints. And this is useful for the various applications like information retrieval, data integration, artificial intelligence, and so on. Now coming to our system for section 138, what we have done is we tried to develop an abstract ontology for section 138. So where we have a party, case stage, and check are the main classes of the ontology. And further, we have a subclasses. For example, when I consider a case stage, I have a subclass resolution and legal proceeding. And when I consider the legal proceeding as a subclass, for that, I have also displayed abstract instances and data properties. So for that legal proceeding, we have a filing of complaint, judgment and order, non-response of non-payment, notice issuance, summons, trials, etc. When I consider a party, for that party, I have a subclasses such as payee party and payer party. Now, as I told, I have considered the abstract ontology. Why I have given the only abstract ontology? Because it forms the basis of our question answering system. And we are also taking efforts, or there are ongoing efforts which are directed towards its expansion and refinement. Recognize its complexity, we opted initially to construct a system based on certain hard-coded questions or some predefined questions. I have called it as a competency questions. So I tried to retrieve the answers for these competency questions. So system retrieves the corresponding answers for these competitive questions. Now, based on this ontology graph, what I have done is I have tried to give the explanation. So check, case stage, and party, which is highlighted in white color, are the main classes, and it has its respective subclasses. Now for them, the properties or the relationships are also displayed, like two major entities can have a relationship such as drawn by, has, stage, issued to, and next proceedings. And it also has a data properties such as name, reasons for check honor, and stage description. Now conclusion. Currently, we have adopted a high-level approach in modeling for the legal processing, and that is related to the bounced cases, focusing on clear and unambiguous elements such as subsequent stages and potential penalties. In future work, we will also expand this to other IPC sections, such as criminal cases, civil cases, theft cases. And then probably with the help of machine learning and deep learning models, we will be classifying them into the categories. So we can also, with the help of this system, any user or any naive user can send a query or send a sentence or the phrases, and he can get the related documents or related case histories for his questions or for his queries. This initial model ensures ease of interpretation and minimizes the ambiguities. Then to enhance the legal accuracy and reliability, we are also planning to engage multiple experts, legal experts, who will provide us the insights and validate our intricate relationship or the knowledge graph or the ontology. This collaboration will also address more complex and potential ambiguous legal questions, ensuring that the ontology reflects accurate legal interpretation and nuisance. These are the references. Thank you.
The chairs, would you like to ask any question?
Question. Thank you.
Thank you, sir.
Thank you, everyone. This brings us to the end of the conference. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 8th and all the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2024. I'd also like to thank our session chairs, Professor Bitan Mishra, for chairing this session, a token to the chair on behalf of Team WS4 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am. I'd also like to thank our session chair, Professor Kangweni Lawrence Mashao, for chairing this session, a token to the chair on behalf of Team WS4 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir. Before we end this meeting, I kindly request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.